Section 9.6, the quadratic formula and the discriminant. The quadratic formula is a method used to solve or find the solutions of quadratic equations. So we've already used factoring, graphing, and square root to find solutions. Now we're going to talk about using the quadratic formula. The quadratic formula is the only method that can be used to solve any quadratic equation, meaning that it always works. And so anytime you're dealing with a quadratic equation in the form ax squared plus bx plus c, you can take those coefficients and plug them into the quadratic formula and find your solutions. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all of that over 2 times a. And we're going to use this formula to find our solutions to our quadratics today. So example 1, we've got negative 3x squared plus 5x plus 2 equals 0. So this is our quadratic, and the first thing we want to do is identify our a, b, and c coefficients. Based on its form, I know my a value is negative 3, b is 5, and c is 2. And I want to take these values and I want to plug them into the quadratic formula. Well, remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And so now I want to replace the a, b, and c in the formula with what their actual coefficient values. So when we plug in the values we have, negative b would be negative 5 plus or minus the square root of 5 squared minus 4 times negative 3 times 2 all over 2 times negative 3. And so now I'll start to simplify this expression to try to get my answers. I'll start with what's underneath the radical first. Well, I know 5 times 5 is 25, and negative 4 times negative 3 is 12, 12 times 2 is 24. So when I evaluate what's under the radical, or the square root, I get 49. And so right now I have negative 5 plus or minus the square root of 49 over negative 6. Well, the square root of 49 is 7, so that means I end up with negative 5 plus or minus 7 over negative 6. All right, right now you're probably going, what does the plus or minus mean? Well, it means that you have to take the negative 5 and add 7 to it, and then you have to do another, and then divide by negative 6, and then you'd have to do another problem where you would have negative 5 minus 7. So it really means you have to separate this into 2 separate equations. So right now I'm going to separate it. Here I'll have negative 5 plus 7 over negative 6, and then I'll have a very similar one where I have negative 5 minus 7 over negative 6. So the top portion of this, or the top one, I have negative 5 plus 7 would be a positive 2 divided by negative 6. So I've got 2 over negative 6, which I know reduces to negative 1/3. So there's one of my values for x. On the bottom, I've got negative 5 minus 7, which is negative 12, divided by negative 6. Well, that'll give me a positive 2. So my other answer is 2. So in this case, x equals negative 1/3, and x equals 2. Let's look at another example. This time I've got 6x squared plus 5x minus 4 equals 0. So once again, I know my a value is 6, b is 5, and c is negative 4. So now I want to plug these into the quadratic equation, and then I'll start to evaluate. So x equals, and in case you forgot the quadratic equation, we know it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug in the values where they belong. So negative b would be a negative 5 plus or minus the square root of 5 squared minus 4 times 6 times negative 4. All of that over 2 times 6. And so now I want to simplify. And the first thing I want to simplify is I want to evaluate what's underneath the square root. Well, 5 squared is 25. Negative 4 times positive 6 is a negative 24. Times 4, or a negative 4 in this case, is going to give me, it's going to give me 96. So I've got 25 plus 96. So that changes my problem into negative 5 plus or minus the square root of 121. All over 2 times 6, which would be 12. Well, I know the square root of 121 is just 11. So I've got 5 plus or minus 11 divided by 12. Remember, the plus or minus means that we have to now set up our two equations. One where we're adding the 11 and one where we're subtracting the 11. So we'll start with, we'll write negative 5 plus 11 divided by 12. And the other one, we'll get negative 5 minus 11 divided by 12. Well, negative 5 plus 11 is a positive 6. So you've got 6 over 12, which is just 1/2. So x equals 1/2. And then on the bottom, you've got negative 5 minus 11, which is negative 16 over 12, which can be reduced to a negative 4/3. So in this case, we know that x equals 1/2 and x equals negative 4/3. All right, so the next example, very similar, but there's something wrong. This isn't the normal form for a quadratic, or at least not what we want to look at. Everything we've talked about so far has had ax squared plus bx plus c equals 0. This doesn't equal 0. Well, in order to make it equal 0, we can move the x and the 20 to the other side of the equation. And what happens is on the right, we end up with just 0. But on the left, now we have x squared minus x minus 20. So we should recognize that our a value is 1, b is negative 1, and c is negative 20. And we want to plug all of this into the quadratic formula. And remember, x equals negative b plus or minus b squared minus 4 times a times c all over 2a. Well, we get, so if we start plugging in the values, we get x equals, well, a negative b would be a positive 1 in this case, because it's the opposite of the negative 1, plus or minus negative 1 squared minus 4 times 1 times negative 20, all over 2 times 1. Well, I'll go ahead and evaluate what's underneath the square root. So negative 1 squared is 1. Negative 4 times negative 20 is a positive 80, so 1 plus 80 is 81. So right now I know I have 1 plus or minus the square root of 81 all over 2. Well, the square root of 81 is just 9, so that means I have 1 plus or minus 9 over 2. At this point, I need to create my two equations. So I've got 1 plus 9 over 2. And 1 minus 9 over 2. Well, 1 plus 9 is 10. 10 divided by 2 is just 5. And then 1 minus 9 is negative 8. So negative 8 divided by 2, which is negative 4. So we've got answers of 5 and negative 4. All right, very similar example here. We're not set equal to 0, and some of our pieces are out of place. So the first thing I want to do is I want to bring the 9x to the other side. But at the same time, while I'm doing this, I want to reorganize this so it's in standard form, which means I want to put the negative 5x squared out in front, then the 9x, then the 2. So this is what I want to start my problem with. And looking at this, I know that I have my a, b, and c values. So I'm going to plug all of this into the quadratic formula. Well, that means I have x equals negative b, which would be a negative 9, plus or minus the square root of 9 squared minus 4 times negative 5 times 2 all over 2 times negative 5. All right, so the first thing I want to do is evaluate what's under the square root. And so I can plug all that in my calculator if I'm using my parentheses effectively. And I should get, in the end, let's see, 9 squared is 81. And then 5 times 4 is 20, or a positive 20, because they're both negative, times 2 is 40. So 81 plus 40 should give me negative 9 plus or minus the square root of 121 over negative 10. Well, I know that the square root of 121 is 11, so I've got negative 9 plus or minus 11 over negative 10. Now I'll break it apart into my two equations. Negative 9 plus 11 over negative 10, and then I've got negative 9 minus 11 over negative 10. On the top, negative 9 plus 11 is a positive 2, so you've got 2 over negative 10. Well, that just simplifies down into negative 1/5. So x equals negative 1/5. On the bottom, you've got negative 9 minus 11 is negative 20, divided by negative 10, which is a positive 2. All right, let's try one more together, and then I'll let you try the last one on your own. All right, so same idea here. We've got our a value is going to be at 1, b is 3, and c is negative 7. So let's go ahead and plug this into the quadratic formula. X equals negative b, so negative 3, plus or minus 3 squared minus 4 times 1 times negative 7, all over 2 times 1. Well, we can evaluate what's underneath the square root first. So we're going to multiply all this together. If we use our calculator in our parentheses, we should be okay. And we'll get negative 3 plus or minus the square root of 37 divided by 2. This is the first time we're dealing with a number underneath our square root that's not a perfect square, but we can go ahead and find the square root of 37, which when you plug it in your calculator, you should get something right around 6.08. And so we end up with 3 plus or minus 6.08 divided by 2. I'm actually going to write that down here. All right, because I'm going to need this space to solve my two equations. All right, so now I separate this into my two equations. The first one being negative 3 plus 6.08 divided by 2, and the second being negative 3 minus 6.08 divided by 2. On the top equation, we've got negative 3 plus a positive 6.08, which gives me 3.08 divided by 2. And when you divide that, you get 1.54 is your answer for x. And then on the bottom equation, negative 3 minus 6.08 gives you negative 9.08 divided by 2 gives me a negative 4.54. And so those are my two values of x. All right, sixth example I'm going to let you do on your own, but keep in mind that your A value should be 2, B is negative 8, and C is 1. So plug all of this into your quadratic formula and see if you can get the right answer. So go ahead and pause the video now, and then unpause it when you're ready to see the answer. So if you've done everything correctly here, you should get x equals 3.87 roughly, and x equals 0.14 roughly. So the last thing we need to talk about is the discriminant. So if you have a quadratic equation in standard form, the discriminant of the quadratic equation is b squared minus 4ac, which is something we've actually already seen. This is the value that's underneath the square root in your quadratic formula. All right? And so we can use the discriminant to determine whether or not our quadratic equation has 2, 1, or no real solutions. And so the way that works is when you calculate the discriminant, the b squared minus 4ac, if that value, when you evaluate that piece, is greater than 0, your quadratic equation has 2 real solutions. If it's equal to 0, it has 1 real solution. But if it's less than 0, it has no real solutions. So basically, if you have a positive answer, you have 2 solutions. If it's 0, you have 1 solution. And if it's negative, you have no solutions. And that makes sense because we can't square root a negative number. All right, so let's give this a shot. All right, so we've got 3 examples here, so let's just go through each example. All right, so the first thing you want to do is identify your a, b, and c values. So for 3x squared minus 2x plus 2, you've got a, b, and c. And they want to know the number of solutions each equation has using the discriminant. Well, our discriminant is b squared minus 4ac. So we're going to plug in the values we have and see what it equals. Well, our b is negative 2, so negative 2 squared, minus 4 times 3 times 2. And so if we plug this in our calculator, we should get our discriminant pretty easily, or you can multiply it out by hand. I know that negative 2 squared is 4. Negative 4 times 3 is negative 12. Negative 12 times 2 is negative 24. So in this case, my discriminant is a negative 18. Since this is a negative number, I have no real solutions. All right, so let's look at the second one. We've got a, b, and c with 2x squared plus 11x plus 12. We want to plug this into the discriminant, which is b squared minus 4ac. So that means we've got 11 squared minus 4 times 2 times 12. Well, 11 squared in this case is going to be 121. And then 4 times 2 is 8. 8 times 12 is 96. So 121 minus 96 gives me a positive 25. Since this is a positive number, that means I have 2 real solutions. All right. And then for question 3, we've got x squared plus 8x plus 16. Which means our a value would be 1, b is 8, and c is 16. So go ahead and pause the video, try plugging all of this into the discriminant, and see how many solutions you should have. When you're ready to see the answer, unpause the video. So we get 8 squared minus 4 times 1 times 16. So when you evaluate this, you end up with 64 minus 64, which in this case equals 0. Anytime your discriminant equals 0, it means you have 1 real solution.